So let's go through a demo on setting up the input and output GPIO ports, and we will be using the LEDs and the user button that we have on the discovery board, and we will toggle the LEDs, or rather we are going to rotate the glowing LEDs. So what the program does here is, when the board starts up, it will be on the blue LED, and then every time you press the user button, it will go clockwise from the blue to the green to the orange to the red. So at any point in time, one of the LEDs will be glowing. At every button press, it shifts one LED in the clockwise direction. So it goes like this. So this is the code. This is what the code is supposed to be doing. So let's get into the code and let's see what it does. So let's put the code in debug. So let's single step, and so this does your PLL settings, and then we do enable LEDs. So enable LEDs is basically configuring the output ports. So all the 4 LEDs that you have, that is the blue, red, blue, green and orange LEDs, we are going to configure those ports. So let's step into the program. Let's step into the function and see what it is doing. So this is the enable LED function. Let's erase this part. That is so I hope you understand what the program is supposed to be doing. So let's erase this part out. And now this particular function that we have is, there is enable LED. Let's see what it is doing. So first of all, the output port that is connected to the LEDs is port D. So it is GPIO port D. Okay. So the first thing that we need to do to even use the port is to enable the clock to the port. Okay. And that is what we are doing in these 2 lines. So we are doing GPIO D clock. Okay. And so we have to go to the GPIO D clock position, right? So it is at the position 3, that is 0, 1, 2, 3, that is the 4th position in the AHB1 ENR register. Okay. Now if you want to see where the AHB1 ENR register is, then come to the reference manual and let's try to find it out. Okay. Let's see where the AHB1 ENR is. AHB1 ENR, and we'll go to the beginning first page and we'll start. So it is RCC AHB1 peripheral clock enable register. Okay. So the GPIO D is connected to this particular peripheral enable register. So there are different peripheral enable registers for our on the microcontroller. So one is this. You have whatever peripheral bus the peripheral is connected to, or what, like AHB1, APB1, APB2, we have to configure that particular peripheral register associated with that particular peripheral. Okay. So we have this AHB1 peripheral register which we need to set up now, and GPIO D is pin number 3, that is 0, 1, 2, 3. So this is the register we are setting up now. And if you go there, here AHB1 ENR is, so this is UI into 32 RCC. So it is in the RCC. Okay. The base is RCC, and so the base is going to be calculated from the RCC base. Okay. And the offset for this particular register is 0x30. Okay. So RCC is reset and clock control, of course. So reset and clock control registers register at the offset of 30 hex is the RCC AHB1. So you have to come to the, I am with the program, I'm showing you the registers in the reference manual, because when you program yourself, it is going to be easier for you to find out where it is. So that's the first thing we program. Let's step through. Let's step over. So now GPIO D clock is this value 8. Of course it is 8 because it's one that has been moved by 3 positions. So this is 8. And then we will do an OR with this AHB1 ENR register. And so RCC AHB, whatever is the content of this register has been, that particular, we do not know what is the content of the other locations, but we know one thing, that is this particular bit has been set now in that register. Let's see which address location this is. That is in the reset and clock control unit. Let us see at which address we have AHB1 ENR. So let's go to the RCC register map. Okay, and let's look for AHB1, and this is in the reference manual. Okay. So we can see RCC AHB1 ENR is at offset 0x30 from the base. Now for us to know the base, we'll have to go to the memory map, memory and bus architecture. So let's see. So in the RCC, let's go up. So in the RCC starts from address location 4002 3800. Okay. So if this starts from this address location, we saw that the offset for that particular register, that is AHB1 ENR, is 0x30. So we'll go to the register map again. RCC AHB1 ENR is 0x30. So what is the address now? The address is 4002 3830. So we'll do one thing. We'll come here, we'll go to the memory browser, and let us go to 4002 3830. Okay, and so this is the AHB1 ENR register. Okay. So now to enable the GPIO D clock, when we step through, the 4th bit, that is the bit number 3, should become 1 here. Let's see if that happens. As you can see, the value has become 0, all zeros, and 8. 8 means 1000. So the 4th bit has become 1 here. So we have managed to make the 4th bit 1. So AHB1 ENR, we have enabled the GPIO D clock. Let's see. So if you go to the GPIO now, general purpose IO, and then go to the registers. The next step is going to be, so sorry, no, not in the GPIO. We will be going to the GPIO from the next line actually. So this one is AHB1 ENR. So let's see where AHB1 ENR is. So peripheral clock enabled register. It's on RCC. The offset is 0x30 as we saw. The actual address is 4002 3830 that we found out from the reference manual. And then we have enabled this, we have set this particular bit, which you can see here. It is a GPIO D. And let's move forward. Now mode ER is, so this is the, now this is a GPIO D mode setting register. Now the GPIO D mode setting is needed because the LEDs are connected to the 2-pin D12, 13, 14 and 15. So we have to set the mode for the ports that the LEDs are connected to, and since we have to drive the LEDs, so those ports have to be made as output ports, right? Obviously, because say you have 12, 13, 14, 15, so these are the ports 12, 13, 14 and 15, and you have these LEDs connected to these ports. Obviously we need to output some value to these LEDs, right? And which is why we need to make these ports as output ports, and that is what we are doing here. So we'll set these ports as output ports. To do that, we have come here, and what we have actually done here is, so let us have a look at the mode, GPIO mode setting register now. So we are going back and forth between a lot of data sheets and the IDE, but this is necessary. You have to bear with me for this. So when we go to GPIO, and I'm sorry, I'm constantly. So this is the mode setting register. So this is the mode set. So this is a general mode setting register. We'll have to look at the mode setting register for port D now. Okay. So we have for the port D, the pins are 12, 13, 14 and 15. 12, 13, 14 and 15. So for pins 12, 13, 14 and 15, we have to set these as output ports. So now let's see what is the GPIO port D base. So whatever is the GPIO port D base, we will be having this register for that, because this is at offset 0. So GPIO port D, wherever it is, this register will be that address only, because offset is 0. So the same address. So let's go to memory and bus architecture chapter here and go down to look for GPIO port D. So this is the map that you have to look into. So GPIO port D starts from 4002 to 0C00. Can you see this? So this is in the reference manual. When you go to the memory map chapter, it is chapter 2 in the case of the datasheet that I have downloaded. Reference manual, it may differ if you are downloading. I don't know if it's a different version, but mostly it should be in chapter 2. So this is the base 4002 0C00. And since, let's go to the register map. As you can see, GPIO-A mode ER is in offset 0. So it is 4002 0C00 only. So let's do one thing. Let us set a new tab and check for that particular register value. So it's 4002 0C00 0x 4002 0C00. Okay, so this is the register that you should see getting changed now. Okay, for GPIO D. So this is the GPIO D base register. So the value is going to change. For example, for GPIO A, the address of this base register is going to change. Though the nature of the register is the same, but there are different base registers for each GPIO doing the same thing. So what we have done is, first of all, we have to clear the bits. But as you can see that since all are 0, we'll see no change here actually. Okay, so we made some change here, that is mode ER, we cleared the pin mode. Okay, but we did not see any change because it was already 0. But now we have to set the pins as output ports. So to set the pins as output ports, we have to. So let's check the GPIO chapter. So in here, these 4 upper registers. So since we have to set 1 0, that is the now we have to set the blue LED port. Okay, because as we discussed in the beginning, we have to set the blue LED first, and then the LED actually moves from blue LED goes off and it moves clockwise and goes around and comes back to the blue LED when we at every press of the user button. So the first thing that we do is set the blue LED, and the blue LED is at port D15. Okay? 12, 13, 14 and 15. So that is the last. So port D15 is 12, 13, 14, 15. So the last one, say for the blue LED, this one, this first we have to set the mode as output for only this port. Okay? That is, we have to set it to 0 and 1. 0, 1. So that is what we are going to do here now. We'll step, and the first thing that we are doing now is we are moving the bit to 24 positions. That is, we are moving 0p, 01. So this represents all the 4 LEDs. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So we are moving this stream of bits into the 24th position. So this is what we are doing. We have a stream of bits. We have calculated it from here to here, and we are moving those bits to 24 positions. Another way of doing it was, more straightforward way of doing this was just declare say 0x1 for the blue LED, and we know that the blue LED is in port D15 and port D15 is here. So what we could have done is we could have just moved that 1 to 30 positions. So we could have just moved that 1 to 30 positions here, and that would have also done the same job. So let's see what happens here if we go to the memory browser and GPIO-D, so 40022600. So this value. So let's step. As you can see, it becomes 40000. That is 4 is 0, 1. Yes, 0, 1, and rest are all 0. So this is the value that this register has. Now, as I was saying, it can be made simpler also. So we'll do this in a slightly different way, but you will see that this value is the same. So we have a breakpoint here anyway. So we will come back here and see the same action again. So let's so we just have, say, 0B1, just 1 bit, and instead of 24, what we do is we move it to 30. Okay, so that 1 we just move it to 30. So let's make it 0B01, doesn't matter. So this 1 moves to the 30th position. So let's make it 30, because we are only working on the blue LED. Suppose we had to enable all the ports together. So for this program we are doing it this way, but in other cases we might need the entire. Suppose we need to enable all the ports, 4 LED ports or 4 output ports together, then we would need that collection of bits. We'll need that, say, 8 bits to be arranged that way, and then move to 24 positions so that you can set all the 4 ports together. So whatever bit pattern you have to make, you just do that and then move it to 24 positions, and it comes here. Okay. So let's try this out and see if we get the same effect. Okay, let's come here. So now we have 0B01. So let's go to the memory browser and enter. So we are here. We are looking at mode ER. So let's step once, step twice. If you can see, it has made the same changes here. That is, it has set this particular pin as the output port. Okay. So we did it in 2 different ways. One was like a bit pattern, moved to 24 bits. Another one was 0B01, and we just moved it to 30 in the GPIO D mode here. So LED pins mode, so it has made this. So something changed here also, so we'll not bother about that right now. So this is how you enable the LEDs. So this is the enabling the output ports. Now let's step and come here. So configure user button is enabling the input now. That is the user button that you press. So let's go into the function once again. Let's step into, and here we have to work on the GPIO A0 pin, right? So we have to enable the, so in the previous case we enabled the GPIO D clock. Here we have to enable the GPIO A clock. So what we do is single step, and here we have to enable the GPIO A clock. Again, the same register that we saw last time, AHB1ENR, RCC AHB1ENR. So let's check for the offset once again. So what we need to do is, let's go to the memory and bus architecture, and we know that RCC is at 40023800, AHB1ENR is at 0x30. So it is 40023830. So let's so 40023830. Now 8 is been set here because we set the GPIO D already. So 8 is here, that is 1000. This one will become 9 now. Once we cross this line, this becomes 9. Let's see if it becomes 9. As you can see, this became 9. That is the GPIO this one got written here. That is in the AHB1ENR, that particular bit got written for enabling GPIO port A. Okay? And that is the reason why you are seeing this happen. From 8 it has become 9. So 1000 has become 1001. Let's see in the register. It was 1 was here. So GPIO D, now we have written a 1 in this register also. That is why it has become a 9 here. Okay, so we enable GPIO A this way. So now we have to clear the bits for GPIO A mode ER. Okay, so what is the address of GPIO A mode ER? It's the mode ER is at the base. So let's go and check for GPIO A address. So GPIO A is at 4002.0000. Okay, so 4002.0000 should be the address where we have the mode register, because that's at offset 0. So let's say we look at 4002.0000. So let's do that. 4002.0000. So this is the GPIO A mode ER register, and by default the value is A8 with all zeros. And if you see in the data sheet also, or reference manual also, it is that value only. So the default reset value for port A is A8000000. So here we are going to enable the GPIO A clock. Okay. So this is what we do. We clear this particular field for the mode. Okay. So we have enabled the GPIO A clock, as you see. We will, and then we are going to come here. So AHB1ENR. Okay, so this clock was enabled in this step. Now we are coming to the mode register. that is this here for the mode register, we are going to set it to, so this is going to be set to 0 0. So what we'll do is we'll clear that field. Clearing that field would be, as you know, do a 1 1 complement of 1 1 and then do this, that is ampersand and then complement of that value. So since it's complemented at this stage, we are not complementing it here. So we do GPIO A mod ER and one step. Okay. So when we clear the pin mode, the value becomes all zeros. Okay. Now, since the value is the same value by default, we don't see any changes here, but it is an input by default. So since though we don't see it, we don't see the value because it's 0 0 only for port A, and then we'll set this pin for active low. Now setting this pin for active low actually does nothing. Okay, we are only doing it for just for demonstration purposes. Okay, that is setting the active low means setting the active low register, okay, for a weak pull down, and we did not set the push pull because by default the push pull is in it's by default it is in push pull mode. So if you want to see that, type, and as you can see, GPIO O type ER, okay, it is in push pull. Okay, that is 0 is the default value and this is for push pull. The reset value is this. So that is the reason we did not set the value for push pull, but then if you want, you can actually, for port 0, okay, you can set it to push pull. That is, just clear the bit here. The bit is already cleared, so we didn't touch it, but this one is also to be configured in case you want this, say, as an open drain. So you have to make this as a 1 or any other pin that you are working on. So that step is skipped here, but that is also an important step if you are working on that. So push pull needs to be set. So we are just setting the active low here, though we don't need it here, but we could do it. So let's see which register that is. PUPDR. So port speed, pull up, pull down. Okay. So this is the pull up, pull down that we are going to configure right now. That is PUPDR. So pull down is for port A. This is the field that you need to set. So for that we did a pull down. So 1 0. Okay. So 0x02. 2 is actually 1 0. That is the value. Okay. And since it's in the first 2 bits, we just do GPIO PUPDR. So let's say where PUPDR is, it is at the offset of 0x0C. Okay. So port A is 0x40020000. So 0x04. So let's see 40020000. Let's make it C. So this is that particular register PUPDR, and you can see that we are right because the start value is 64000000, and then when you step once, as you can see, this has been set in the PUPDR register. Okay. So we have configured the user button. Mind it, we left out one step because we don't need it because it's 0 by default. Okay. There are some more steps which are 0 by default. For example, here the buttons mode is 0 by default. Configuration set to port 00 as input port. Actually, this is set by default. Okay, 00. So you might leave this configuration as is also. Okay, this line can also be left out. But nevertheless, we did it. Pull up, pull down also we did here, but this doesn't have any effect. When you work on it, don't touch this line. I've just written the code here to show you it works fine, but then better to leave it. Now, the particular input pin that we have, the user button, is active high. That is, active high would mean when you press the button, it becomes high, and when you release the button, it becomes low. Now, if you want to see the electrical connection, electrical characteristics of that particular user button, then you need to come to in the user manual, you need to come in the end. That is in the mechanical drawing. In the mechanical drawing or electrical schematics, there you can actually see this is the user button that you have, this one. So this is your user button. This is the wake up, this is the reset button, and this is the user and wake up button. So as you can see, this one, it goes, there's a VDD, there's a resistor here, so it is not grounding the signal. So when you press this button, this makes it active high here. Okay, so this is the active high button. Okay. In contrast, as you can see, the reset button, if you press the reset button, the black button, you are shorting the pin to the ground, the reset pin to the ground. The path is this, and when you are when the pin is not connected, this pin is connected to VDD, so it is active low. So that is, when you press the button, it goes low, and here when you press the button, it goes high. Otherwise it is low. There's no connection. When you press the button, it goes, because there's a capacitor here, so that's how it is. So this I think is an RC circuit. So that's what that completes the configuration for your user button. Coming back to the diagram once again, when I said that the user button is an active high button, it also means the pin is in the pull down configuration. When the button is not connected, as you can see, this pin is connected to ground. Okay, so this is the pull down configuration. For the reset button, when the button is not connected, this pin is connected to VDD. So this is a pull up configuration. So an active high button has a pull down configuration here. An active low button has a pull up configuration. Obviously, because for an active low, when you press the button, the value has to go to 0. So there has to be a pull up resistor, supply through pull up resistor somewhere to have the pin at an active high state for you to make it active low when you press the button. So now we will move to the next phase, that is, let's come out of here and let's not bother about any of this. So we have set both the ports, and this is from our other examples, so let's not worry about that part. Let's come here. This function has not been defined, that is why it is showing this issue. So now let's see, let's single step. So now let's get into the function called power LED. So in the power LED function, we are going to output some value through the ports and blink or light up the LEDs. So let's go in. So do a step into. Now, for the sake of this program, so this part is a little tricky here. For the sake of this program, as you can see in the GPIO-D ODR, so ODR is the output data register. Okay, we saw the output data register. So in the output data register, we have to light up, we have to send ones to all the LED positions. Now this is a bit tricky, and I'll tell you why we are doing this. That is because only one LED port, that is the blue LED port, has been configured as the output port now. So you have the 4 LED ports that we have configured. So the blue LED port has been configured as the output. Rest of the LED ports are as inputs. So even this configuration was done in the GPIO. Now in the GPIO output register, if you feed a 1 to all these registers, all these bit positions all together, only the port that is designated as the output port will let the signal out and glow the LED. It will power on the LED. Even if you feed something in here, since these are configured as input ports, these LEDs are not going to glow. Okay, so that is the trick here. So that is what our intention is. So when you step through this program on your board, you will see at this stage, when you look at your board, you will see that the blue LED is glowing, even though we have output all ones and we shifted it to 12 bits, 12, 13, 14 and 15. Okay. So if you go to the GPIO now, the GPIO address for this is the port mode, this is the output speed, this pull down, GPIO input data, this is the output data. So you have to write something here. Okay, so I have written in all these 4 bits, but since these 3 are configured as input ports through here, that is the GPIO mode set register. So I've set these as input ports and only this one as output port right now. Even if I output some values through here once, only the blue LED will be, it's like it will only filter out the blue LED value, and it will not let any other bits pass through to light up the other LEDs. Okay, so this is a flag that we are setting, and we are getting into the main program logic now. So we are setting PA0 button value as 0x1. So this is the button value we are. So now we have to wait for the button input. So what we are doing is in this particular while loop, we are waiting for the button to be pressed. So we are not following interrupt method here. Interrupt method we'll see later in the interrupt segment. So since we have not yet learnt interrupts, we are going to do it through the polling method. So we have the while loop here. So in the while loop, we are actually checking for something. Okay, so we are checking for the button value here. Okay, and the button value is GPIO IDR PA value. So we are checking. So if the button is pressed, then this button value is going to change. Okay, so I will show you how the value changes now. At this stage, the button value is 0. Okay, and then I have not pressed the button. Okay, so so the button value is 0 now. I have not pressed the button, and then if I cross this, okay, since the button value is 0, it is going to not get into this loop. So this is what is going to happen. It comes here, it sets the LED flag to be 0. Okay, and then it goes back to the beginning because the button is not pressed, and that is the reason the button value is 0. Now what we'll do is, and to see get the button value, we are doing an AND with a 1 for that IDR register. IDR register is this one, that is the input register for GPIO. So we have the input data register. We are just ANDing a 1 with this particular value and seeing if anything has come here. Okay. When you do it in the interrupt method, the method is entirely different. So when you press the button, it raises an interrupt and you go through there. You don't check the button here. We'll see that during the interrupts segment. We will also study that. We'll configure this button to the interrupt pin actually as an interrupt. So the mechanism is going to be entirely different. But in our case here, we are doing it in the poll method. So now what I'll do is I'm pressing the yellow button. Sorry, I'm pressing the blue button on the board. Okay, so the blue button is pressed. Now let me step through. Now let's see what the button value is. The button value, as you can see, is 1. I can release the button now because the button value, it has already got the button value. Okay. Now it checks the, okay, I have to keep the button pressed. Okay, so because now it goes in here. So sorry about this. The button value here is not used here. I've just placed it to show you that the button has been pressed. Okay, but you have to keep the button pressed until this if statement, because the if statement is again separately reading the button value. Okay, so you don't release the button here. Release the button only after it crosses the if statement. Otherwise, it will read the button as a 0. So let's go in there and let's step through, and then we come to the move LED function. So let's see what the move LED function is doing. So it does something interesting. In C, you can use the percentage operator, that is a remainder operator, to say have a number incremented for any value and then reset to 0. For example, here we want the number to be like 0, 1, 2, 3, and then to go back to 0 again. Okay, so the number, so anything for a percentage is basically remainder, right? So percentage operator gives you the remainder for a particular number. So I think all of you have come across the remainder operator. So when you do a percentage 4 or percentage any number, it actually goes from 0, 1, 2, 3, and whenever the number is divisible by this value, the divisor, the remainder is 0. So ideally what you are doing is, if it is 4, the number is going to go from 0, 1, 2, 3, and then again it is going to get set to 0, 1, 2, 3, and so on. So this is the purpose of this particular statement. And why? Because we have 4 LEDs. Since we have 4 LEDs, we will actually be moving a particular bit position in to the left by 1. So as we discussed, we have the blue LED on right now, right? So now the blue LED position is in the extreme end, and we are taking that as a 0. So LED, these bits. So we first clear all the LEDs. So whatever in the mode register, okay, the mode register, we saw this previously. So we are redoing the output pin setting here again. If you see, so we are shifting the mode register, and what we are doing is, this is a very important line. That is, so this is just to move the LEDs around. Okay, this is not a part of the port setting, of course. This is just to move the LEDs around. We are doing 24 is the number of positions that the mode starts from. So GPIO, if you see GPIO mode, 24 is the mode that it starts from here, from the 24th, because it's pin 12, 13, 14, 15. So we are here. We are anyway considering this as a 0 here. So that's okay. Okay. So now what happens is, we are trying to zero this area out, and then the first value that we have is, say position is 0, and we are declaring it as static. Okay, so static means, for this particular function, even if you come out of this function and goes anywhere else, it is like a global to this particular function, right? So you are aware of static within a function. So static is, if you're not, then this is how static works within a function. You declare a variable as static. Even if you move out of that particular function, that variable retains its value. So when you come back to the function again, whatever the value was last time, so if it was 1, then that value, it continues from that value. So as of now, static variable value is 0. Position is position percentage 4. So for 0 percentage 4, it is 0. Okay. So now it comes here, it clears the mode. Okay. And then here what it does is, so position into 2. We do position into 2 because whatever bits we have, these are 2 positions each. Okay. So whatever position we set, since we are setting it as an output port, and output is 0 1, so it is 0 1 0 1 here, 0 1 0 1 here. Okay, position into 2 means if it's 1, say now that position value is 1, 1 into 2 is 2, so it goes to 2. If it's 3, it goes 6 places. If it's 4, it goes 8 places. Okay, it is like that. Okay, so 0 1 2 3. So 3 means it has to go to 6 places. 1 2 3 4 5 6 places. Okay, this one. So we are not considering 4 here, though the logic is this is the 4th place, but so position by 4, and then when we go in, so position is 0, position by 4 is 0 now. So position is 0 now. So GPIO mode ER, we are clearing the mode here. Okay, like previously, we are just clearing the mode, and then what we are doing is we are trying to write the bit positions here. So and this is just a variable that we are setting, which we will OR with the mode ER register later, but this is the position calculation that we are doing. So if you go one further, LED pins mode is let's make it hex. Okay, hex 0 1 0 0 0 0. So this one, if you now light the LED, and we have, okay, so I'll come to that. So now we increment the position by 1. So the position is now 1. Go down 1, and when you do LED pins mode, right now you will see that the green LED is glowing now on your board. Okay, the green LED is glowing because we have moved to the 24th bit and position is 0. 0 into 2 is 0. So this is actually gone to the, we have only enabled this one as output, rest are all zeros. So these are all inputs, this one is the output, and we are anyway feeding 1 1 1 1 into the output register previously, where we did the light LEDs, if you remember. So we did the light LEDs here in the main, where we power LED, where we are feeding the value 1 1 1 1, and we are so that value is constantly fed. Okay, here what we are doing is we are moving the output configuration in the GPIO mode ER register. So the logic is in the GPIO mode ER register, keeping the output values constant here in this GPIO output data register. So in the output data register, we have these values fixed. Okay, so it's 1 1 1 1. So we are not touching this value after we set it. What we are doing instead is we are altering the modes here. That is, we are moving 0 1, that is output, from here to here. Only one of these fields is 0 1 now. So 0 1 moves from here to here. This becomes, all rest becomes 0 0. Then 0 1 moves from here to here, here to here, and this is how it goes. Okay, we could also have set all of these as output ports, and then for the input port, that is output data port, we could have moved the digits from here to here, here to here, here to here. That also would have been possible. That is another approach. What the approach that we have taken is we are just moving the output configuration itself to a different port. Now the reason why I have written the code like this will become apparent in the interrupts segment. So when we talk about interrupts, there is the button is this move LED will become an interrupt at that point. So when we press the button, this function will be at an interrupt service routine at that point, and that time it's going to be an LED blink function. So the sysstick is going to keep blinking the LED, and what we do here is we just move the output position, and so that cystic, so the program started as blinking all the 4 LEDs for cystic. Then from that we came to blinking 1 LED at a time, and we would just move the output modes from one position to the other, and thus the LEDs are going to move. So when you step over and come here, and when you see this here, I have not pressed the button, so it comes here. So the while loop goes here, and then when I press the button again, I press the button again, it goes into this particular loop. Okay, let's go into move LED now. So in move LED again, you will see that the position value will change. So now the position value is 1. Okay, if the position value is 1, then this move position is going to be 2. So it is going to go to the next field now. That is the mode setting field. It is going to go to the next field. When it goes to the next field, it is going to come here. That is the mode set for 13. Okay, then it will go to the mode set for 14. So mode set for 13 and 14 is, again, if you want to see here, user manuals, buttons, LED. So first of all, we have the blue LED in 15, then it goes to 12, 13, 14, 15, and then again 12, 13, 14, 15. It goes on like this. Okay, so LED 3 is a user LED, that is the orange LED. Okay, connected to port 13, then 12, 13, 14, 15. So it is green LED, then it goes to orange LED, then it goes to the red LED, and then it goes to the blue LED, and that is how it goes on rotating. So now let's see at where it is going to, which LED it is going to glow. So now it is position into 2. So 24 plus position into 2. So the position value is 1. The position into 2 is 2. So it is 13. So if you look at 13 is the orange LED. So when you come here, the orange LED should glow. Okay, so when you look at your board, the orange LED should glow. Okay, then next one should be, so the position value should increase to 2 now, since I have done position plus here. So position value is 2. So next time when it comes back, it sees 2. So it is 2 into 2, 4. So 24 plus 4. So it goes to 12, 13, 14. 14 would mean it will go to this place. 14 is this one. So your red LED is going to glow, and then 15 would mean, so then it is going to be 15, or it will move to 6 places. Okay. So you are back to it. You will come back to your blue LED. So if I keep the blue button constantly pressed now, and I step through, so it has come here, and LED flag 1, and okay, so let's see what the value of move LED is now. Okay, no, it didn't take the button pressed. Just a moment. Let's keep the button pressed. It went into the loop. Let's do a move LED, and then let's see what the position is. So position is 2 because it came back, and it is retaining the position because of the static declaration. Okay, it's goes down, and here it's position into 2. So 2 into 2 is 4. Okay, so it's moved 4 positions. Okay, so if it's moved to 4 positions, it is here now. Okay. This one, it is here now. So it's moved to position 1, 2, 3, and it is moved to the 4th position. So what is LED 14? LED 14 is this, your your red LED. So when you cross that, here, when you come here, you'll see on your board the red LED is glowing. And then let's go out back to the back here, LED flag. So the LED, so we make the LED flag as 1. Okay, and then we so this is because once the LED is pushed, okay, until we release the LED and press it again, even if it comes in here, it is not going to, otherwise it will toggle. If you do not do this, if you do not set the LED flag, just comment this out and see what happens. You will see all the LEDs glowing faintly, okay, because what will happen is it will actually do the job, but it is going to, if you press the LED, it is going to toggle the LEDs multiple times. It is going to move the LEDs multiple times, because within that time the while loop is going to loop many times. So this flag is to safeguard for that. Once it moves the LED, when it comes to the loop for the next time, it is not going to move it. But in the else, this means you have released the button, that time it makes the LED flag as 0. So that is the reason why this is being done here. Okay. It's like setting the state of that particular LEDs. Okay. So then going back, let's press the button again, user button, and now we will go into that move LED function. See, so here the LED flag has been set to 1. Okay, and we are, so I have left the button now. Now it is going to work. So what I was doing is I had the button held. So when I held the button, it was not coming out of this loop. Okay, so you have to release the button and then single step through, so that now the flag is cleared. Now when you press the button and come in, so get into the move LED function and see what the value of position is. So the position value is 3 now, okay, because this position was incremented. Now when it is 3, then it is going to be 3 into 2, 6. So we'll have so it starts with the blue LED and it ends with the blue LED. So now you will see the blue LED glowing again when you come here, because that time it is moved to the position value is, now the position value is 4. Here it sets it to the blue LED, comes back here, resets it to 0. So the position again goes back to the first, that is mode for the 12th pin, and pin 12 is the green LED. So let's see, pin 12 is the green LED. So this is a demo on how this particular program works. So we learnt about how to set the GPIO pins as inputs and outputs. We managed to switch on and switch off LEDs at button presses. We saw one code where we also set a flag to prevent the button from the move LED to be triggered multiple times, and thus we have completed the demo for using the buttons and the LEDs in pulled mode.